So I work at Facebook, but I don't work on React. So if you have anything bad to say about React, I won't be insulted. I'm not emotionally involved. I work on social plugins, which means not the Facebook site itself, but like buttons and all those stuff that people put on their websites. So everything that is outside the Facebook site. So we recently rewrote this comments plugin and the moderation tool using React, and that's what I want to talk about. So I'll start with a few introductory words about React if there are people in the audience that are not familiar. So it's a library for building web interfaces. Actually, no longer only web interfaces. So we're talking about applications because React is not suited for every web page out there. So when you say applications, that means you have built a page once, but then this page mutates over time because of user actions, because something happening on the server, or simply with the passage of time. So whenever something happens, you have to update the DOM. And the DOM, there are problems with the DOM, right? Browser inconsistencies, the API is kind of wordy and verbose. Updates are slow. Event handlers, right? They work differently in different browsers. So one example, everybody at some point or another had to do something like this, right? So let's say you have a bunch of data and you want to present a table. So what are you going to do? You go create a table, create a row, create a cell, add the data, and so on and so forth. OK, what if there's a link in one of those tables? OK, we need to create a new element, we set the href, and so on and so on. And then the data changes. Oh boy, what are you going to do? Do you keep references to all those objects, DOM objects that you've created, so you can update them? This is crazy. There's tons of them. Are you going to check every single? Do you want to find the exact node that changed so that you can change it? So probably not a good idea, because you end up spending a lot of time just querying for nodes that you want to update. How about rebuilding the whole interface? Because once you did it, right? Once you created this big table, so why don't just get the data, put this whole thing in a function, and rebuild it again? And that's pretty much what React does. But there are certain problems with this, right? What if you had some event handlers in there, right? On click or something like this? Are you going to create leaks, memory leaks? What if there was an input field that the user typed something? Are you going to just wipe it out and start fresh? That's not nice. So React solves this by using components, right? It's all about components and their data. So if you want to build a table with React, you say, OK, I'll have one big table component, and I have a bunch of rows and cells components. And then I have some data. I give the data to my component and let React deal with displaying that properly. So I just define the interface in those components and give you the data. And what if the data changes at some point? You don't have to do anything with the UI. You don't have to touch it. After all, once you've defined how it's supposed to look like. So here's the new data. React, you figure it out. So how does React figure it out? How does it deal with it? So there's the idea about the virtual DOM. So everything happens in JavaScript land. So you have three structures that represent how it eventually will look like in the DOM, which is just simple JavaScript objects. And when something changes, you take your virtual DOM, your representation before and after. You look for any differences, compute the minimal amount of updates that you need to do, and batch them, do them at once so that they're efficient. About events, React implements this idea of synthetic events. It uses event delegation for performance reasons. So although in your component you might say table cell on click do this and that, all of these event handlers are attached to the top of the application, and we used event delegation to figure out what exactly was clicked and what should happen. So those events are cross-browser W3C compliant, so no longer you have to deal with making your own library for events or having, is it IE, is it event.src element, or is it target, and so on. And there's some tiny little fixes, like, for example, in an input field in React, when you have on change, that event happens as you type, not as you blur, as it is in the browsers. So the benefits of the virtual DOM is that everything happens in the JavaScript line, which means it's much faster. So you can use the same idea to do server-side rendering, or at this point anywhere really with React Native. You can render this thing in a native application, or you can render, there's already projects to render in a canvas, render in 3.js, and so on. So components. How does a simple component look like? So what you have to do is, the only time you touch the DOM is when you say, okay, this is where my application should live in the DOM tree, right? It doesn't have to be that the whole page is one application. You can have certain bits and pieces, right? React was developed with the idea that Facebook is a huge site. You cannot just stop everything and rewrite everything from scratch. So you can just start by replacing little bits and pieces here and there. So you tell where your new React application would live, and then you say, okay, render my widget and give it some properties. And so version 0.14 was released last week, and there are some changes. So the change with this is that now you have React DOM. So now the DOM part of React is completely divorced from React, and the idea is that you don't have to render to the DOM, right? You can render natively or anywhere else. So an example of a little bit of more complicated components. So this is the component again. So it might have a head and a body, and within the body you have all the HTML elements are represented by React DOM spans and Ps and divs and all that stuff. So you have somewhere to start building your custom components. And this thing can become, if you look at that example, right, okay, no here means there's no properties like here. And then you have children. Whoops, what happened? All right. So this can become a little hairy to keep track of all those brackets and so on. And so that's why JSX comes into the picture and lets you use XML, HTML-like syntax to define those components. And this is where, when React was initially released, people went, oh, what is this XML doing in my JavaScript? This is ugly. No, it cannot possibly work. So that's why you don't have to use JSX. You just, once you start, you figure out that it's much simpler and more convenient. But JSX is completely different technology from React. And in fact, React doesn't use JSX internally. So you don't have to use it. It's just more convenient. So because JSX is not really valid JavaScript, right? You cannot run this thing in the browser. And that's why you need to transform the JSX into JavaScript. And there's this JSX command. You give it the source and the build directory, and you're done. But since last week, JSX is no longer developed. So now you can use Babel. All right, I have a little blog post how to, if you've already used JSX, how to migrate. It's very simple. But you basically use Babel now, and same thing, give it a source and a destination directory, and your code is transformed. So the JSX is really simple transform. It keeps the line numbers, so when there's an error, you can see the same line number that you typed in your source code. You saw that there's the error. Allows JavaScript, so that means you don't have to study or learn another templating system. You just use JavaScript in there. You open square brackets and do any JavaScript that you want. When you learn JSX, there are a few tools that may be useful. There is a compiler from JSX, so you can see exactly what's happening. If you want to migrate a project, you can paste HTML and get the JSX representation. And in Babel, there's also a repo that you can use to see what's happening before and after the transformation, just as a learning tools. So let's see a couple of components. So this presentation is written in React, of course. Right. Why not? So we have the whole thing is a slide component. And inside of the slide component, you can have children. And this is one example of the children, which is called a list. All right. So imagine you're doing some sort of to-do list or presentation tool. So you can type stuff here and update the list, or you can click. Let's see. You can click enter and commit, and then keep going until it messes up your slides. So let's see how these two components are done: the slide and the list. So the slide is what we call a stateless component. It doesn't maintain any state. It's very static. So the only thing that you have to implement in a React component is a render function. That's the only requirement. And there's other things you can do, but this is the bare minimum. So in this case, we say, OK, my slide will be just a div. And inside, there's going to be a heading. And my slide will take a property called title. Let me show you quickly. So this is an example of a property, right? When you define, let's say, slide, title, awesome. You have access to those properties via this.props. So I'm just going to render the title in the H1, and then this props children gives you all the children of this component. So I'm just going to render them right there, regardless of what these children are. This is how the same component looks like in ECMAScript 6 land. See, now we have classes in JavaScript, right? So you extend the React component, you implement your render function. So it doesn't say function anymore, right? With ECMAScript 6, we don't have to type function all that often. And there's also something called a functional component. So instead of defining a class, or instead of creating this thing with a bunch of this object with a bunch of methods in there, you can just define a function. So using the arrow function, you can say, OK, this component takes some properties. And the only thing it needs, really, because it doesn't maintain any state or anything, it's very simple. It will just return how this thing should look like. So there's no longer this.props. And if you want to make it even more magical, right, you can use, so this is a stateless functional component that uses the ECMAScript 6 destructuring assignment and return implicitly. There's no return, and this is an arrow function. So you can write JavaScript like this these days. And if you want to see what's happening in the back, so this is it, the function that we created with the arrow function is just a function. It takes something. We assign it to those local variables, and then do this interface when the JSX is transformed into JavaScript. So this was about the stateless slide component that has a title and anything inside. So what about that stateful list that can mutate over time when you type more things? So first of all, we need to define the initial state. That's why we have the get initial state. And the initial state will be just the properties, just the initial items property that is passed to it. So state is something that you maintain in your component, and props is the stuff that comes from the callers, from the users of your component. And then the render function is a form that can, when you click enter, right, it will call this handle submit. So again, even though these look like inline event handlers, it's still event delegation, so you don't have a whole bunch of event listeners inside. Then this is the JavaScript part that I was saying. You don't need any special syntax. Just open the curly braces and write JavaScript in there. In this case, it's a simple map where you iterate over the items. Here they are. The items, and you just draw a li. And at the end, another li. And when you change, we'll handle this change. So yeah, this is a simple implementation of the handle change and handle submit, right? So when you type something, okay. When you type something, right, we take a copy of the current items. Then we do some simple array manipulation, and at the end we call set state. So whenever you call set state, that's where the render function of your component is called again. So now that you have updated the items, you have added one more. Your render function will be called again, and will React will iterate again. It will call this function, create a virtual DOM tree, compare, and we'll figure out, oh, there's only one item added. So it's not going to rebuild the whole list and the whole form. It's just going to append one more list item. All right. So one question that people often have when they come to React is, okay, when should I use state and when should I use properties? And this is sort of an analogy with object-oriented programming, right? So properties is whatever is passed to your component from the clients or the users of your component. So you can think of them as, if you have in object-oriented programming, if you have a class, then all the stuff that you pass to the constructor when you create it. And these are properties, and you're not, you shouldn't mutate those properties yourself. And in fact, it's now deprecated. It used to work that you can say this props dot something equals something else, but it's not a good idea, and it's going to cause a warning and maybe just not break in the next version. And state is, you can think of it as your own private properties. How do you maintain the state of your component is totally up to you. So how do you go about building an app? So this is the, let's see, developers. So this is the comments plugin, right? This is a third-party commenting system that sites like TechCrunch use. So you can put this at the bottom of your article and have a comments section. Right, you can type comments here, you can tag people. And as soon as you click post, we do an optimistic update. We put this thing inside. And then we do the actual update once we received OK from the server, right? So then you can delete, edit, and so on. You can reply. So you can change identity, right? If these are pages that you manage, you can post a comment as yourself or as one of the pages. All right, no. So that's pretty much it. You can like stuff. A little comment section as you would expect. And the moderation tool is for the moderators of your app or yourself. You can use to just approve, ban users and whatnot. You can see what's available up there, batch operations and so on. So that's what we rewrote using React. It was a pleasure. There were new people in the team new to JavaScript, new to React, so they were able to pick it up and be really happy with it. Said, oh, now I see what all the love is about. It's so easy. You don't need any special skills because just defining interface, managing the state, and simple. So when you design an app, right, you want to divide and conquer, right? Split everything into small components. Expose as smaller surface as you can. Not say, okay, this is my component that takes 50 properties, right? If it takes so many variables, then it should be can be split even further. And you can maintain the state, or if it's simpler, stateless component, you don't have to. Oh boy, I don't have much time. So components communicate with each other. If it's parent to child, you use properties. Otherwise, you need some sort of event system. And that's where the idea of Flux comes in, to managing your data flow. So this is the diagram that, it's unidirectional data flow, right? So it makes it easier to reason about the application. Something happens, the dispatcher, you can think of it as just a proxy. The store is where all the data lives. So something happens that updates the store, and then which updates the view. The view is the actual React components. You can trigger some actions from the view. Let's say delete a comment or something like this, and it goes back to the store and updates the view. So as an example, to create one comment component, right, it can only take just one property, which is the ID of the comment, and then you go to the store and say, hey, give me all you got for this ID, and then use that data, text, and so on to display. When you have an action, let's say on click of this comment, something happens. So you reach into the actions and say and do something. So the actions, they update the store and then emit an event that you know that something happened. The store, simple, has getters and setters, right? And there's this thing called mixin event emitter that makes events fire. In the actions, right, this is the action that we want to take. We have some data. We do maybe XHR requests, massage the data in any way. At the end, we update the store and send an event, and we call it a change event. OK, something changed. And in the main application component, this is the big app that has a bunch of comments in there. Let's say component did mount is where you do some initialization work. Then you say, OK, I'm going to listen to the change event, and then do an update. So force update is the same as set state, only when you don't know the state. Something happened, you don't know what, but you're going to trigger an update. So there is the idea of pure rendering functions, which are functions that only take properties and state, and that's all they need. And you can implement a method called shouldComponentUpdate, which takes the state before and after and the properties before and after and returns true or false. If it's just a performance optimization, if nothing changes in your component, you don't have to call the render function. So this is an example of impure function, because in the render method, it's reaching somewhere to get the data. If we want to make it pure, now we can only read from the state. So this is a pure render function. And to maintain the state, you read the data in that getInitialState. And when something changes, you listen to the change event, update the state, and that's how you know that something changed. So there's the idea of mixins. You just include the pure render mixing, which is a very simple thing that will just compare shallow comparison of the properties and state before and after. All right, a few words about types. Because when you have a big application with a lot of people working, people like their types. They want to just be first line of defense, that you're not doing something awful. And if there's any automated checks that can be done, why not? So we do 3 types of types checks. First, you can use React prop types. You can define what type of properties your component takes. All right, so you can define these prop types and say, okay, these are the properties that I take. I take a name, and it's required. It should be a string. Then I take a bunch of things that is an array of numbers, and it's also required. You can say one-of, which is kind of enumerated list of values that you take. And you can also define shapes, right? You can say key value pairs like this. And if you just type react.prop types, you see all the prop types that are available to you. The other type of checks is using the flow. Flow is a static type checker for JavaScript. And you can annotate your variables, the return value. You can also have custom types, not only numbers and strings and so on. You can have this sort of type where you can say, okay, these are my, this is a map of things that I'll take. You can import, right, so to share types between components. There's the website tryflow.org if you want to try and just get a hang of it. The last type of check we do is a runtime check, which is only in development. It can read the same flow annotations, and at the top of the function, we just inject a check. So because flow is a static type analyzer, and this is a runtime check. So when a function is called, you check, is it of the right type? And if not, blow up in development or be stripped in production. You may be curious how a typical JavaScript looks like these days at Facebook. So we define a module this is a convention. You opt in for flow checks because again, you have a bunch of JavaScript code. You cannot suddenly start using flow all over the place. So you just opt in to flow. We use common.js to define dependencies. And at the end, the convention is at the end of the file, you only return one thing, which is the same as the module name. So we use a bunch of ECMAScript 6 things, which is really nice. Destructuring assignment, which is the same as var prop types equal react.prop types. Classes, mentioned this already. Arrow functions. We do the flow annotations for all new code. Commas, right? To maintain blame, finally, we can use commas everywhere, even for the last argument of the function. Object short notation, it's the same as var object equals 1, column 1. And even more commas, right? You can put trailing commas now and maintain blame. You can put them in the end of the object. Use let and constant, finally. So it used to be that we had a number of homegrown JavaScript transformations using Esprima, modified Esprima, but now we switched to Babel. If you don't know what Babel is, you can check. It's really nice. So if you start using it, suddenly you have access to all the ECMAScript 6, all the good stuff. I wanted to show you a demo of React Native, but I'm out of time. But it's pretty simple. You just initialize a new project and then open this Xcode project. So React Native is now available for iOS and Android. You need Xcode for iOS applications, but the only thing you need to do is just open this thing and let's see. So I created a new project here. So now the only thing you have to do in Xcode is open this thing. So the first time it runs, it will do some stuff. The only thing you need to do is really, you don't have to know anything about Xcode. You can use your text editor. And the only thing you need to do is just press play here. And then you have, okay, I'm over time already. Then the iOS simulator opens up. and then you can see your the application that you're working on. Pretty big because of the resolution. Anyway, all right. So this is the good stuff. You can use Command D, right? And you get, what is it? Not here. Here. Command D, and you can have live reload. So edit your stuff. You can debug in Chrome. Let me just give you a quick example. So right here in the Falsy values, we have index, iOS, JavaScript. All right. So let's see. You can type something here, and as soon as you save, it's right there. All right. Same thing. You can use debug in Chrome, and okay, I'm over time. You can debug in Chrome. You can put breakpoints, so it looks very much like web development. Only you're creating a native application. All right. This is all I had for you, and yeah, feel free to talk to me after this and ask any questions. And sorry I went over time a little bit. Thanks.